Welcome. This is part 7 of our video series in chapter 5. This video covers nested loops. Before getting to the nested loops, let's talk about deciding when to use which loop. As you know, there are 3 different kinds of loops. There's a while, a for, and a do while. The pretest loops are the while and the for, and the do while is the post-test loop, meaning that the body is executed, then the check is made whether to continue. So for a while loop, we have seen some computing patterns, and a while loop is used principally when you do not know at the beginning how many times you must repeat. And there are 2 typical patterns. One is read, check, use, and the checking is done in the condition within the while. And the other is check and use. Read, check, use is typically driven by the input data. That is, something in the input data, when encountered, should cause the loop to terminate. The check use pattern has more to do with some computed value that is updated each time the loop is executed. In other words, there are times when the calculation of an output may control the loop instead of the input. A do-while loop is used principally for input validation, where the pattern really is read, check. You're checking for invalid data. If it's invalid, you will read and check again. The pattern can also be used in the case of use, then check. And finally, the for loop can be used when there is a predetermined count or some sequence of values that need to be exercised. All right, let's talk about a nested loop. And I want you to visualize the notion of something being one-dimensional. One-dimensional, it means that the data, either the input or the output, can be viewed as going in one direction. So if I wanted to write a program that produced this output, notice now there's nothing magical about 5. This could be 1 to n, or where n is some variable. But this output goes in one direction. We can either print the output horizontally, or we could print it vertically, but it only goes in one direction. So we want to produce one line that's containing this, and that line goes in one direction. So what's the solution? Just produce the sequence 1 through 5, and we know how to do that. It's just a for loop where we generate the sequence that we want to output. We output the sequence, and then we skip to a brand new line. Now here's a two-dimensional problem. Two-dimensional problem says I want output that goes horizontally, but I also want it to go vertically. And if you look at it carefully, what you have here is that you want to produce 5 lines containing the line 1, 2, 3, 4, 5. But what's at the root of this? At the root of this is the ability to produce one line. And the solution to this two-dimensional problem is simply to repeat the root problem 5 times. How do we repeat anything 5 times with this loop? So our solution will say, repeat something 5 times. What is it we want to repeat? Whatever we did to produce one line. So the complete code will look like a loop that controls the lines, and the body of it will control the output in one direction. Think of it this way. This loop goes vertically. And whatever is inside here will go horizontal. All right, so let's put a little comment here. So this is going horizontal. So we have vertical, and horizontal. And notice that all we're doing is putting in here what our solution was before. So that's the fundamental nature of a nested loop. You want to repeat some solution that you've already worked out. So as a rule of thumb, when we write nested loops, we should always think of working from the inside out. Here's another example, and we'll give you some terminology now. A nested loop is a loop that is inside the body of another loop. We call that loop that's inside another loop the inner loop. The surrounding loop we call the outer loop. Notice that I have added a comment at the end of the block to indicate which loop I am talking about. I've also used colors to clearly indicate the inner loop versus the outer loop. Alright, here's another example. I want to generate 3 rows of output. 1, 2, and 3. And each row contains 1, 2, 3, 4 columns. 1, 2, 3, 4 columns. The data that I output is going to be the row number followed by the column number. And as you know, the output must be produced horizontally. We don't have printers that go up and down. Printers go left to right. So the outer loop gets fixated on row number. So once row number 1 is set, then we output the value for the first column, second column, third column, and fourth column. Again, the inner loop is moving horizontally. When the inner loop ends, it does an inline which jumps us down to begin a brand new line. So we make a vertical move down to the next line. The inner loop will again take us horizontally across and then down one. All right. Here's another example. If I have 10 students, each with 4 test scores, how do I compute the average for each student? Well, the solution is pretty simple. Just repeat 4 times whatever it takes to calculate the sum. And we actually have an error here. Let's fix it. This is really an error, because what we want to repeat 4 times is set the sum to 0. This goes away. Sorry about that. Okay. Kind of messy. Alright, here's some notes on a nested loop. The inner loop goes through all of its repetitions for each repetition of the outer loop. It's almost like a wheel within a wheel. The outer wheel is moving more slowly than the inner wheel. The inner loop repetitions complete more than one time. And the total number of repetitions for the inner loop is the sum of the repetitions for each repetition of the outer loop. In the previous example about the output here, this is wrong again. Okay, with that, we're going to terminate this, and we will come back with some coding examples.